I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline. And I'm joined by Mary Gannon, who's editor-in-chief of Fluid Power World. Mary, welcome to the podcast.
Thanks for having me, Jim. I'm glad to be here.
Mary, I've been dying to talk to you for a long time because you're editor-in-chief of sort of the title of record for the fluid power industry, and I'm an old-time millwright. You sort of worked my way through college and auto parts plant, and man, I spent an inordinate amount of my time messing with hydraulics and pneumatics, basically. So it's it's amazing. A hydraulic oil can get in places you would never imagine. Yes. And it is hard to launder out of your clothes. And but the question is that what I was hearing, and this is, I'm not going to bury the lead, I'm going to get right into this. 30 years ago, 25, 30 years ago, I was hearing from the linear and rotary electric actuator people that fluid power is dead. Hydraulics industry dead. Pneumatics dead. He said, we've got stuff coming down the pike here, ball screws, we've got linear motors, essentially. It's all electric. The future is 100% electric, no more fluid power. What happened to that vision? Have you heard that?
I've been doing this for 20 years, so clearly it's not dead, and I don't think it's dying anytime soon. I did hear it, and I still hear it to this day, but I do think it's become more balanced, especially as we go into more electrified machinery. I do think people realize that there does need to be a change with hydraulics, but I think, you kind of said earlier that, that hydraulic fluid can be anywhere, and it can be messy, but it has one big advantage, and it's still going to have that big advantage for a long time, and that's power density. And the electrical and the mechanical options just don't have the same power density that hydraulics has. Even pneumatics, it's not as powerful because it's a lower pressure air, but you still achieve a lot of powerful work with just 100 psi of air. You need a much bigger ball screw actuator or something like that to accomplish the same amount of work in a machine.
Yeah. Now it's interesting you mentioned that because it's in the injection molding industry on the plastic side, the all electric machine has made significant inroads and has replaced hydraulics in all but the very, very largest machines. And we all thought that, okay, that's the harbinger of the future. We're going to see, Komatsu backhoes are going to be of electric actuators on the things. And when I looked at, say, the metalworking industry, metal forming, that didn't happen. I mean, you didn't see a massive takeover for forming, punching, presses, that kind of technology. Is it that the hydraulics just got cleaner, more reliable, better? Is it a competitive thing?
I think that's definitely the case, and it can continue to get better, but because the biggest issue with electrified, like mobile machinery, like you said, Komatsu, is the energy efficiency. They need to be as energy efficient as possible. And so a lot of the big hydraulics manufacturers are really working on making their systems and their pumps and their motors and their cylinders more efficient. And so, yes, it has gotten better. But again, I think it goes back to durability as well. And you did mention Komatsu, but maybe 3 or 4 years ago, Bobcat came out with a small, compact backhoe. I forget exactly what it was. A small, compact machine, anyway, that was 100% electromechanical. There was no hydraulics on it at all, which is very rare. And it was going to be driven by ball screw actuators. I haven't heard anything about it since. It was going to be available for sale, and I'm sure that some have sold, and then I'm sure it does have some applications, but the durability of hydraulic cylinders compared to the durability of ball screws, I think that's another big advantage that it has. So.
Yeah, it's really counterintuitive. One of the things that always fascinated me about hydraulics in those mobile applications like construction equipment is I can't imagine a worse environment to expect a hydraulic system to operate in than in things like construction or off-highway equipment. I mean, even in the confines of a factory, I found it difficult to keep foreign material out of hydraulic systems, from breathers and past seals. And I like that. Can you imagine if you're putting this on a machine which is designed to work underwater or to dig a trench, at a construction site? It's amazing.
I just saw a press release back in the early spring about a whole big subsea actuator that was all 100% electro. And I was like shocked by that. I was like, wow, this is interesting. This is new. And then I was talking to the folks at Bosch Rexroth who they use their Haglunds motors very heavily in the subsea, and they call those electrified, but they still have hydraulics running through because it just really is sort of the safest, most reliable system when you're underwater. And obviously, a fully electric system can work because I'm not sure what company it was that was offering that, but they are coming out there. And I think at this point, we just have to realize that both technologies need to work together. And that's where the electronic controls really are going to come into play heavily as we move forward into the future of electrified machinery.
Yeah, yeah. One thing I've noticed on the hydraulic side too that surprises me over the years is how much tighter hydraulic systems are now, especially rams. And is it? I've often wondered this: is it something about are the seals better, the seal materials, the finish on the rams? I mean, it's something is going on here that you're just not seeing the kind of weeping of fluid that you used to see routinely.
Yeah, and I think again, it just comes down to the fact that the manufacturers are realizing that they can't get away with the ways of the past. And yes, the sealing companies are always coming out with new materials that last longer, that seal better, that are stronger, more durable. And I think too, like the fluids are becoming different. They can withstand higher pressures. I think every different component manufacturer in the space is really working to make a better system, um, because the electrics are coming and they are getting better. So if we want to stay in industry, we need to get better, and so they are. They really are, and they're. I think if you're a big manufacturer like Danfoss or Bosch Rexroth or Parker Hannifin, they're all going into making complete subsystems that are fully electrified. And so they're partnering both sides of their companies, the electric side and the hydraulic side, to make sure that they are fully compliant and working together in the most efficient manner.
Yeah, yeah. Mary, what's the environmental aspect of this now? Because it's one of the thing was a given, which was in factory operations. I mean, sawdust on the floor to
Mhm.
mop up hydraulic oil was almost a universal part of operating a factory.
Yeah.
And now, more recently, I talked to factory owners, especially in the West Coast, California in
Oh
particular,
yeah.
who had VOC rules, and their VOC rules were so strict that I mean, if you just charge an aerosol spray bomb in a men's room or something, and you're gonna set off an alarm. And I thought hydraulic systems generally use reservoirs that are vented to atmosphere. They're breathers on these things.
Yeah.
So I mean, is this how much of these hydraulics manufacturers they have to think about environmental issues now?
I mean, it's obviously a huge aspect of it, and I think that comes into play again with the fluids. Obviously, most of the fluids are probably still typical oil based, but the bio based fluids have really come a long way, and more manufacturers, like even Shell, like typical companies you relate to petroleum, are coming out with really powerful brands, and they're being used more in waterways and agriculture systems and things like that. But I don't see that would be an issue that those would eventually move into the industrial space, and we might phase the petroleum based ones out. Maybe not. I mean, they do offer certain characteristics that the bio based ones just don't have. So it'll be kind of interesting to see what happens. But yes, for sure, complying with the environmental concerns is obviously key here. And I just even think about, like, from going into factories back in my 20s. And I'm one of those weird people. Like, I loved the smell of like hydraulic fluid and injection fluid before I even really knew what it was. I was like a 22-year-old recent college grad, but I felt like it was like the smell of manufacturing. And now you go into a manufacturing facility and it's a completely different situation, which is a good thing. But we're still making amazing products throughout our country, and so we don't need to have all that smell out there. So there's definitely ways we can do it. And I think too, like you talked about the breather, the breather technologies, I think, have advanced too, and they've gotten better as well. So they probably are filtering out a lot of that nastiness that we're used to from back in the day.
Yeah, yeah. The fluids. People will talk a lot about fluid there. I used to handle a lot of it because we would order it in 55-gallon drums, and
Yeah.
we were losing so much of it around the factory. You're literally using hand cranked, wobble pumps to pump the stuff out by the
Mhm.
gallon to keep those reservoirs filled up. And for those of you out there who work in modern manufacturing and that sort of clean, sweet air and white marble floors, hydraulic oil tastes terrible, and it is surprisingly difficult to get out of your clothes.
Mhm.
So be thankful that you have a modern working environment. But the question I've often had about the fluids now is we regarded hydraulic fluid as a commodity item. purchasing department in our factories, they basically they didn't care who the vendor was. Essentially, it's whoever's cheap and whoever has a drum in inventory that can get it over here in 2 hours. Basically, sort of would get the contract. And we mix fluids. We mix fluids of different types from different men, different suppliers, essentially freely. Basically, the name of the game was downtime was unacceptable.
Yeah.
Basically, and and if that essentially, if that forming machine is down, basically you top off the reservoir, and heck, you'd put Gatorade in there if you had to keep the thing running. And we knew even then that's probably not a good practice, but the general rule of thumb was the fluid doesn't matter that much. But I see now it matters a lot. It's
Mhm.
not just even a matter of viscosity now. I mean, you got to use the right fluid, don't you?
Absolutely, and mixing it is a bad idea because they're so heavily formulated, and they have additives that are specific to certain applications, and you need to kind of get it tested regularly. And I mean, the whole system is, at least it should be, much more regulated. There's a lot of companies out there that have much better filling systems, like you talked about the wobble pump. Like they have a whole canister system where they can measure things more directly, and it's more clean because obviously you don't want to have dirty fluid running through your system. So yeah, I think things have definitely changed in that regard. And like I said too, like there's so many different types of fluids out there now, and the fact that the pump manufacturers really test those on their systems and make sure that they're working right. But going back to those old days of just using whatever you wanted isn't going to happen, I don't think. And in fact, I mean,
Very.
it's such a huge thing too. Like there's a whole conference, and it's not just about hydraulic fluids; it's about lubricants and all that. But the reliability conference, like reliable plan, and that I think it just happened maybe last week. But they are really on top of the importance of monitoring your systems, keeping your fluids clean, making sure that you're using the right kind. So yes, I mean reliability and maintenance go hand in hand. And so I think fluid is the lifeblood of any hydraulic system, and so keeping it clean, cool to the temperature it should be at is really crucial. And I think we're having an issue with skill shortages, but the people that are out there maintaining it hopefully are really educated on what they're doing now, and they're not just they realize now that doing that anymore is not quite kosher.
Yeah, yeah. I mean, keeping fluid clean in my experience had basically been about changing filter cartridges,
Mhm.
and then taking a piece of chalk and then putting the date you changed the filter cartridge on the wall behind the machine, right?
Yeah.
And I understand now that some sophisticated operations are doing things like spectroscopic oil analysis even
Mhm.
to find out what's going on. So it's PM's a real science now rather than just
Absolutely.
a checklist thing.
Yeah,
Yeah.
regular analysis and having even installed diagnostic systems on a machine is absolutely normal now for sure.
Yeah, yeah, I understand. Now you can find those metal finds at levels you can't detect. I mean,
Mhm.
I recall you dip your finger in and then rub it between your thumb and forefinger, and if you could feel grittiness in there, you probably ought to do something next week.
Yeah, and like you said, you don't really want to do that with hydraulic fluid because it's not something you want to have on your skin if you can avoid it, right? So,
It really
yeah.
isn't. Mary, tell me about pumps because one thing is heat, of course, is the enemy of every system, and rejecting heat's always been an issue. And yeah, I understand that a big part of the efficiency, maybe the major part of the efficiency of a system from a power consumption standpoint, is the pump. And we've seen an evolution from the sort of the radial pistons and the swash plate designs, and there's some really exotic looking stuff now.
Mhm. Yeah, absolutely, and that's where the big changes are coming. And this year at Bauma, um, all three of the major, Parker Hannifin, Bosch Rexroth, and Danfoss, they all launched, brand new pump designs. One of them was even, I forget, I think it might have been Parker, was a vane pump, which usually is not sort of a new one that you kind of see. It's usually the axial piston that's kind of the more popular.
Yeah, yeah. I think vein. I'm thinking volume, not pressure.
Yeah, but I mean,
Yeah.
they have created something that's very efficient and very very powerful. And so I think today the pumps have come so far, and that's where the key thing is they're taking these pumps and they're partnering them with those electronics, and so they're very efficient. And again, like hydraulics has always been only like 80% efficient, and then once it runs through the whole system it drops so much. So getting those pumps up to 90 to 95% efficiency, which a lot of them have done, has really made a big difference in the system for sure. So yeah, that's the change that is continuing to come over the last several years.
Yeah, I'm hearing stories that some of the more efficient pump designs running cooler means that you got some cost savings because you're not oil cooling as aggressively as before. And in some cases, I've heard of some applications where with some of these advanced fluids now, you can do away with external oil cooling in some cases if the duty
Absolutely.
cycle lets you.
Yes, yes. And that's the thing too is so Josh Cosford is one of our contributing writers, and he has been writing about heat as a contamination source for years. We can't have excessive heat, and so working on that and making sure that these pumps and all the other systems can run a little bit more efficiently without generating that heat is the biggest thing.
Mary, we've got so much to talk about. I've got like a dozen questions I'd love to fire at you about this technology. It just amazes me, what a sort of a high-tech science this has become compared to just ramming fluid into a ram and watching a piston go back and forth. It's awesome. Mary, will you come back on the podcast in the future and tell us about latest developments?
Absolutely, I certainly can.
Well, thanks for joining me.
Well, thank you for having me, Jim. It was fun.
That's it for today's Industry Insights and Trends podcast, brought to you by engineering.com. If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D printing, aerospace and defense, digital transformation, simulation, or a weekly roundup at engineering.com/subscribe. For our deeper engineering series, visit engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on engineering.com TV. Thanks for tuning in.